Let's examine how to find local max and min using a graphing utility. First thing I want to show you is how to use a graphing calculator. We're going to graph the function f of x equals 2x cubed minus 3x plus 1 for the interval from negative 2 to 2. So first off in our graphing calculator, we're going to push the y equals button, which is at the top left-hand corner of your calculator. Here you'll be listed with a bunch of functions that you can type in. For our function for today, we're going to type in 2. The variable x is next to the green alpha button, x, and then the caret symbol is the power, so raise it to the third power. Bring the arrow button to the right, so you bring it down so it's no longer in the exponent here. And then we type in minus. Don't get minus confused with the negative sign. This is a negative sign. So minus 3x plus 1. And going back to that minus sign, notice how the subtraction sign is fairly long compared to if I enter in the negative sign. It's a little bit on the shorter side, so that's how you know whether you have the right symbol correct. Okay, so I'm just going to go ahead and delete that there. All right, so my function is 2x cubed minus 3x plus 1, and then I can go ahead and click on graph. You'll notice here that my graph is, I would say, fairly zoomed out. I've got a lot of extra white space that I really don't need. It's kind of distracting me. And so that's why in this problem here, it did ask us to do it within the interval from negative 2 to 2. Currently, if I push the window button on my calculator, you'll notice that my scale says that the x minimum should be going from negative 10 all the way to an x maximum of positive 10. And that's not what I want. That's why I'm getting at this zoomed out graph. I'm going from negative 10 over here on the left to positive 10 on the right. So I don't want that. I want to zoom it in. So going back to my window screen right here, I push window. You'll notice it's highlighted in red right now. I want to change my x min to negative 2. So I'm going to go ahead and clear the negative 10 and push, remember, the difference between subtraction and negative. If you do subtraction symbol, I think you'll actually end up getting a domain error. Your calculator will not be able to enter that in. So you push negative 2, and then I'm going to go to my x max. Instead of 10, I'm going to make that a positive 2. So I'm going to clear the 10 and type in positive 2. All right, it didn't say anything about changing my y values, so I'm going to leave that alone. And now I'm going to go ahead and push graph. Ah, that's much better. My graph has been zoomed in. It's like taking a magnifying glass and just looking at this central location to see what's going on with our graph. Okay? All right, the directions tell us to find the local maximum or local minimum of our graph and also determine where the graph is increasing or decreasing. So let's start off with the local max and min. As we had talked about earlier, the local max occurs within some open interval I such that some point is the highest point. And hopefully you're seeing that that's occurring right around this area here. Okay? Now I don't know exactly what that point is, but my calculator will be able to do that. How do we do that? Well, one way to do this is, well, actually let's go through two ways. One way is actually not going to be very accurate. This is what I would not recommend you doing. Many students might want to push trace and just go along the graph and just kind of figure out where that is going to be the maximum. And it's kind of hard to figure that out if you're just going left and right. You're not going to find that exact value. So instead, what I would recommend is pushing the second button, then push trace again. When you do second and trace, you're actually going to this the word above that says calculate. You want to calculate something. So we're going to calculate, and now you should have a screen like mine. And what we want to calculate is the maximum. And if you look at the different options there, that would be option number 4. So I'm going to go ahead and highlight number 4 and push enter. My graph asked me for a left bound. Now this is giving us the bounds of the open interval I. So let's go ahead and go to the left of that maximum. Somewhere here is pretty safe. I definitely know that this is not the maximum where my cursor is at now. So I can go ahead and push enter here. I can even push it right here. You know, there's just so many different options you can choose. Let me just go ahead and select it right here. Now notice here, this is where my open interval starts. And then my calculator asks me for the right bound. So now I'm going to go to the right of my maximum. I know my maximum occurs somewhere around this area, but I'm going to go a little bit further just to be safe. Maybe somewhere here. I could stop here if I want. I could even stop here if I want. It doesn't really matter, right? So I'm just going to go ahead and select any one of these points, let's just say right here, and push enter. Okay, and then my calculator asks me, do I want to guess it? Yes, this is where I want to guess my local maximum. So I push enter, and there it is. My cursor is now at the point negative 0.707, and the maximum actually occurs at this y value of 2.414. Okay, so we can go ahead and say that the local maxima occurs at the value of 2.414 when the x value was at negative 0. What was that? 707. Negative 0. Here. Okay, negative 0.707. There we go. Okay, so local maxima occurs at 2.414. That is the maxima. It is the value of 2.414 when x equals negative 0.707. Let's find the local min now. So where does local min occur? Along the graph, we want to see the lowest point, right? Right around this area. We want to find it in this open interval I around this point here. So go ahead and do the same thing. Second, calc. And now we want to find minimum, which is number 3. Go to the right over here. Somewhere around here. This could be my left bound, just somewhere in this location. Okay, push enter. I'll do it right here. Push enter. And then now I want to go to the right bound. So I know that my minimum occurs somewhere here, but go somewhere to the right of it. I'm pretty safe right here. I'm also safe over here. I'm also safe over here. It doesn't really matter. Okay, so I just push enter. So I'm saying, let's find the minimum within this interval of these two dotted lines. Push enter. And there we go. Our min occurs at negative 0.414, and that occurs when x is 0.707. Okay, so let's go ahead and say that. That the local minima occurs at negative 0.414 when x equals 0.707. Okay, now let's find when the graph is increasing or decreasing. Okay, we know that the graph is increasing as it comes up from this location here, right? We're going all the way here at negative infinity. It comes up, and then it increases all the way until you reach the maximum. And once it reaches the maximum, that's when it starts to fall and decrease again. Okay, so we know that our function is increasing on this interval here. It's also increasing on this interval here, right? Where it starts from the smallest point at the min and works its way up. Okay, so in terms of how we can write that, we can say that the graph is increasing on the bounds from, I can't write that, negative infinity to, right there, negative infinity to the value of where our maximum was occurring at negative 0.707. And we'll do that close bracket saying it's increasing on that interval. And it also occurs, it also occurs on the bounds from where that maximum was, the minimum was starting at. So we'll do close bound. And where does it start? It started at this point right here, right? Where was that x value? We said the minimum occurred at negative at x equals 0.707. So we'll say from 0.707, and it goes until, well, that graph just keeps on going, right? The graph keeps going up and up and up and up and up and up. So it's going to infinity. So this graph is going to infinity. And we'll do open parentheses because we're saying infinity, it has no bounds. Okay. Then the graph is decreasing. Let's go here. It's decreasing on what interval? Let's see. on our graph is decreasing from the maximum all the way to the minimum. It's falling down. The y values get smaller and smaller from max to min. When does that occur? When the x value is going from each of these values here, right? Negative 0.707 to 0.707. Okay, so decreasing on, and then close bracket, negative 0.707 to positive 0.707. Close bracket. Right there. Okay, so we've answered our questions, how to find the local max, local min, and where the function is increasing and decreasing.